Okay, welcome back to our next lesson. This is section 2.10. It begins on page 37 in your notes, and this is something called translations. Now, a translation refers to an actual movement of your graph. For example, you could move it up or down, or you could move your graph left or right. So what would we have to do to an equation to actually get it to move? Well, the actual rules are listed right here. They're listed right there on page 37 in your notes. The first rule right here says if you replace x with x minus a, the graph will actually shift a units to the right. Now, that might be the opposite to what you expect would happen. You might expect that subtracting a number from x should move it to the left, but it doesn't. It actually moves it to the right. It's the opposite to what you might expect. Replacing x with x plus some number will shift the graph, that number, to the left. Again, the opposite to what you might expect. A vertical translation, down below that, if you replace y with y plus b, now you might be thinking, well, shouldn't that move it up? Well, the answer is no. Again, it's the opposite to what you would expect. The graph will actually shift down b units. Now, I'd like to point out that typically in an equation, like if you have y plus, I'll just say 3 equals x squared. Now, what that will do is that will take the graph of y equals x squared, the basic parabola, and it will actually move it 3 blocks down because you're adding a number to the y. But in general, typically, you wouldn't see your equation written as y plus 3. Usually the 3 would be written over on the other side. So the equivalent equation would be y equals x squared minus 3. So that does move 3 blocks down. It moves your graph of y equals x squared downward 3 blocks. You just have to remember that it's basically that minus 3 has been moved from the side with the y. And finally, if you change y, if you replace y with y minus a number, you might think that should move it down, but no, it does not. It moves it actually up b units. All right, so we're going to look at some examples of this now. Here, graphically, they're illustrating exactly what happens to your functions. So the first one right here shows that if you replace x with x plus a number, look what happens to the graph. The blue graph is your original graph. You can see that every single point moved 3 blocks to the left. If you replace x with x minus a, now again, the original graph is the blue one, every point shifted 3 blocks to the right this time. And here's the vertical translations. If you graph y equals f of x plus b, now remember, if that b was on the other side, that would be y minus b, wouldn't it? So that would actually move your graph up. And you can clearly see in the diagram there, that's exactly what happened, 3 blocks upward. And finally, if you graph y equals f of x minus b, but remember, if the b is brought over, that's actually y plus b equals, that would move your graph, every point on your graph, 3 blocks downward. Now, what they show on the next page, page 38, they want you to actually take these 4 functions right here. Y equals x squared, or f of x equals x squared. That's what we consider to be the base graph, the original graph. And all you're going to get there is a parabola, probably the simplest parabola you can graph. Then they want you to graph the same thing as y equals x minus 2 squared. So you're subtracting 2 from the x. What do you think is going to happen? They want you to graph this one here, h of x, they're calling it. You can think of that as a y plus 3 equals x squared. Well, that should, I think, is going to move it down, isn't it? And the fourth thing they want you to do is actually graph p of x, they're calling it this time. Think of it as y again, equals negative x squared. Now, that is not actually a translation. That's actually a reflection. What I'm going to do here, instead of getting you to actually graph this manually, I'm going to just open up this beautiful website called desmos.com. And I'm going to actually type in here those equations. So there's the first one I graphed, y equals x squared. And you can see it's the base parabola, the simplest parabola that there is. Very straightforward. And now we're going to compare that to the other graphs. So the second one they wanted you to draw, and again, I'll just type it in here in decimals, was g of x equals x minus 2 in brackets squared. Well, I'm just going to say y equals, and then opening bracket, x minus 2, closing bracket, and then to the power of 2, and look at that, all right? So y equals x squared, that's your red one. You can see that this little box right over here tells you the color, you see? So there's the original graph. Whoops, no, I can't use my marker on this. Well, okay, I'm learning new things every time, every day. Oh, now maybe I can. No, I can't. So anyway, the blue graph, you can see, because we replaced x with x minus 2, it actually shifted the red graph 2 blocks to the right, perhaps the opposite direction you might expect. And let's try the third one now. Y equals, and I'm looking through my notes here. Remember that it was y plus 3 equals x squared? Well, we're actually going to remove the 3 over. You could put it on that side. You could leave it there. Decimals allows you to do that. Y plus 3 equals x squared. And look at that. You see that? It did get moved down, didn't it? 3 blocks, every point. All those parabolas, by the way, are the same exact size. They're all what we call congruent. They might look bigger or smaller, but only because you can see more of it. And the very last one they want you to graph was y equals negative x squared. Now, like I said, that is not a translation. That's actually a reflection. And you can see it got reflected in the x-axis. And the reason it got reflected in the x-axis is because what really happened there, x was not replaced with negative x. The y was replaced with negative y, and then it got moved over to the right-hand side. And that's why you have a reflection in the x-axis right there, okay? So let's go back here now to our textbook. I hope that all came out well in the video. Let's go back to the textbook, and here's the graph they expected you to graph everything on, and you can if you want to. Let's have a look at some of these examples here now on the top of page 39. Let's try these, okay? What do we have? It says, if the point 1, 2 is a point, let me just highlight that, 1, 2. That's your original point. It's on the graph of some function, y equals f of x. Find the corresponding point on the graph of, and now look what they're doing, everyone. Look at what they're showing us here, okay? This indicates that x was replaced with x plus 2. And what you have to remember, what that does, is it moves it 2 units to the left, not the right, to the left, kind of the opposite to what you might expect. Now, if you're still not sure what the coordinates of the new point are, just make up a simple set of axes. 1 and 2 would be approximately right there, say. Okay, 1 to the right and 2 up. That's the point 1, 2. So if that was moved 2 units to the left, it would move 1 unit to there. Then it's on top of the y-axis. 1 more unit to the left puts it right there. So what's the coordinates of that point? Well, it becomes negative 1 and 2. Really, all you did, if it moves 2 units to the left, subtract 2 from the x-coordinate. If you were moving units to the right, you would add things to the x-coordinate. Let's look at B. What does this indicate is happening? Y is equal to f of x plus 3. Now remember, if that was on the other side, that would be y minus 3. That would indicate that the point moved 3 blocks upward. And if you take 1, 2, and if you move that 3 blocks up, think about this graph again. Look, here's my original point. If that moved 3 blocks up, it would go, boop, boop. It would end up approximately right there. So you're just adding 3 to the y value, and that would become 1, 5. Very simple types of questions. No workings really required here. Okay, what about part C? Now these last two, by the way, these are not translations. These are reflections. Okay, these could have actually been asked in the last section. Excuse me. So what happened in C? What happened right there? Well, the x never got changed. The sign of the x never changed. But this negative right there is actually a result of the y turning into negative y. All right, so really what happened was that gets reflected in the x-axis. So again, look at this point right here. Think of that point in my simple graph. If that reflected in the x-axis, it would just basically bounce over the x-axis, the same distance down below there. You see that? There's your new point now. I should be using a different color perhaps. Well, that point is actually 1 comma negative 2. All right? Well, really, that's what you should expect to happen. Remember what I just said. The y became negative y. So the 2, the y coordinate, became negative 2. And for D, the last one, notice that what happened was the x was replaced by negative x. That would indicate a reflection in the y-axis. So it would come from the original point here again. Oh, by God, look at that. It would land right on the same spot as A did. Or just think of it as change the sign of your x-coordinate. So that will become negative 1 comma 2. All right, so there's your new points. There's where they all end up. Well, let's look at number 3. What does this one say? For the function f of x equals 2x squared minus, or plus 3x, sorry, minus 1, what will the function be after a reflection through the x-axis? Now, why are they asking that question in this section? That would have been a better question to ask in the previous section. All right? A reflection in the x-axis really means, remember, that you're changing the y into negative y. So you're going to get negative f of x equals 2x squared plus 3x minus 1. And now, of course, you would bring that negative to the other side. So here's what the new function would be if you reflected it through the x-axis. Okay, so you're going to get negative 2x squared minus 3x plus 1. Now you could test that. You could actually put them into decimals and see if that's what happens. But that's a reflection. That's not a translation. Now number 4 is a translation though. Again, they give us the function. It's exactly the same function they had in the previous example. What will the function be after a vertical translation of 3 units down? Now, think about that carefully. If you're moving it up or down, you're adding or subtracting to the y. You're going to replace the y with y plus 3. Okay? That will move it down. But then there's a horizontal translation, so you're adding or subtracting something to the x 2 units to the left. So that means that wherever you see an x, you're going to replace the x with x plus 2, the opposite sign to what you might expect. So that's what we do to our equation. So take your function, take your equation, and you can change that f of x into a y for now if you like. That's okay. And so what you're going to have is y plus 3 is equal to, there you go. See, I replaced the y with y plus 3. And then everywhere I see an x on the right-hand side, I replace the x with x plus 2. Now be careful, because notice that you have to square that binomial. Okay, so that's not just x squared plus 4. There's actually 4 multiplications you have to do there. And then plus 3 in front of x plus 2 again. Now that's just a distributive law. And then subtract 1. Now all you're doing is simplifying, everyone. So y plus 3 is equal to, this will be 2 in front of. Now when you do your 4 multiplications, you're going to get x squared plus 4x plus 4. And that's when you group your like terms. And this second term will become plus 3x plus 6, and then minus 1. I'm kind of running out of time, so I'm going to speed this up a little. If you now multiply through this first set of brackets there, sorry, by 2, then take this 3 at the end of the plus 1, or y plus 3, bring that to the other side as well. Here is the function that you end up with. This is what the new equation is going to be. Now, if you bring it over, you're going to get, and now make sure you do the workings and check this to make sure it's correct, because I only have 30 seconds left. 2x squared plus 11x plus 10. So again, if you tested those, if you grabbed both of those functions on Desmos, you would clearly see a movement of 3 units down and 2 units to the left. Okay, so I'll stop there. You please try the practice questions on pages 39, 40, and 41. Okay, so that's it for this lesson. And I'll get the next lesson ready now in just a moment. Bye-bye.